Right, good afternoon, everyone. Hi, I'm Eng Tat. I'm from National University of Singapore, and today I'm going to share with you the future of immersive intelligence. A bit of introduction. I graduated with a PhD from Mixed Reality Lab. After that, I joined a US tech company working on AR/VR solutions for oil and gas, for aviation. We started with entertainment, with mixed reality game for elderly and children, and then I went on to found a VR company, and then was briefly investment before I come back to NUS. Right, so I've been back to NUS for the last 8 years, and I'm currently the assistant dean of research at the College of Design and Engineering, and I'm also a director for Institute for Engineering, Design Engineering and Leadership, I founded the lab, Immersive Reality Lab, which I'm going to share many of the work that we do in our lab, how we combine AI and AR/VR. Right, so one of the first things I do when I come back to the university is to set up an application lab, because in the universities we have many research labs, but many of them just focus on writing papers and doing research. But for me, I think AR/VR, AI is about application, right? I think it's very, very exciting, the development we had. In the last 20 years, I was involved in the research in AR/VR. I think there's a lot of opportunity, and I really wanted to work on immersive application. So one of the mandates that we do in our lab is that we wanted to work with industry partners to look at how we could combine the use of AI, generative AI, large language models, and AR, augmented reality, virtual reality, mixed reality. When we combine them, how can we transform the industry to kind of promote higher productivity, to kind of transform new use cases for them, right? So we do immersive technology development, generative AI research, user experience, interaction, and multimodal interfaces as well, right? Truly trying to converge the reality. And I think it's exciting where we are today. When I first started my research, I still remember 20 years ago, the headset was like really bulky, and it cost like $50,000. We have a VGA on each side of the eyes, but it's mono, right? You don't see stereo. And this over 20 years, we have, I think earlier speaker, Meta, was talking about AI glasses, right? We have such a portable device that can be there everywhere, right? I think that's very, very exciting. And on one hand, on the virtual reality, all the simulations are getting very real. You have real humans joining in. It's all connected. You feel that you're part of it, right? Anyone have watched the Ready Player One? Yes, I can see a number of hands. I think we are approaching that. Not yet. It still messes up the hair, but we know. We are slowly getting there, but it's getting a lot more realistic. It can track your facial features, eye tracking. It can have cameras looking out, understanding your world. So I think VR is getting exponential, right? At the same time, when we look at mixed reality, right, augmented reality, you can bring things into the real environment. We have glasses like Meta glasses, right, Ray-Ban glasses that can actually have cameras looking out, right? And not only that, we have an explosion. Besides AR, VR converging, I think the future in the next 5 to 10 years, we are looking at a world where we can't tell what is real, what is virtual. It's truly immersive. It converges to this reality. And of course, we have many names, right? We have metaverse, we talk about it. In our lab, we call it immersive reality. Of course, Apple call it spatial computing. I think there's many words, but the idea is that real and virtual world is connected. All of us are very invested in real and virtual world, right? Through our digital devices, through our daily interaction, physical interactions. I think that is converging, right? That's going to happen. But I think what is really interesting is now, in the last few years, with ChatGPT, with generative AI, large language model, we have a true understanding of the world, right? Meaning that when you look at things, right, it's not just text. It can be videos, images, audio. It's able to make sense of that environment. And that is the generative AI, large language model, the intelligence part. When you combine that with AR, VR, I think it's truly explosive, right, what we can do. And we term that immersive intelligence. I think there's a lot of opportunity here. And today I'm going to share with you a few things that we do in our lab that we are trying to explore this together with other industry partners. So we have 3 groups in our lab. One is healthcare group. We work with medical school. We work with hospitals. We try to disrupt and change how doctors are being trained, how surgeons are performing the surgery. We're working at aviation with Singapore Airlines to train pilot. We do train cabin crew, right? We also work with heritage groups, media to look into creative media, the entertainment, the expression, right? So there are three main groups. We have big undergraduate students who are working on the projects, capstone projects. We also supported through the PhD and master students and researchers. That's our typical model, and this is not complete because we have a big part, which is our industry partners. Every single project that we do in the lab, we wanted to have industry partners that we work with, right? So, and these are some of the projects we have done in the lab. I was going to share a bit of a snapshot. We have developed more than 20 applications that are currently run in the hospitals at various stages. So on here, one of the projects we've done was basic cardiac life support training. If you know the resuscitation, in terms of somebody, you need cardiac arrest, you need to resuscitate the person. AED, and CPR training. We did that with Sengkang Hospital, one of the community hospital here. Robotic surgery, using the Da Vinci system, we created a virtual reality system to train surgeons how to perform surgery on the robotics thing. That's the VR aspect, but now we are moving towards using AI to understand, what the surgical scene, to understand what the surgeons are working on, so that provides the feedback to the surgeon, right? And then childbirth delivery, I'm going to share a bit more details on that. Using virtual reality, mixed reality, how do we train doctors to deliver babies, right? And operating theaters, patient safety, orthopedic simulation. For orthopedic simulation, we created AI patient. The doctors, the students are able to then talk to an AI patient to kind of do clinical assessment, and they can also carry out the physical examination. Right, what is interesting, if you see the pupillary examination, this is with ophthalmology department with NUH, right, National University Hospital. This patient here is actually not a real patient, but a hologram, right? So we use HoloLens. We overlay that patient in the clinic's settings when there is no patient around. So that allowed the medical doctors to perform training, directly with the AI patient. Right, we have a project on mixed reality ultrasound, where we take slices of ultrasound, we combine that into a 3D volume, we project it back to the anatomy. So in the next time when the doctor is doing bedside scan, instead of just seeing one slice of ultrasound, they can see the full volume of the anatomy they're looking at. And that greatly reduces the understanding of what they are looking at, and then reduces the gap between the expert and the more novice young doctors, right? HoloVein imaging, looking at using HoloLens, some sensors to look at the vein imaging and able to use AI to segment the vein and then project it back to the body. So when you do IV cannulation, you can see where the veins are, so it's not so painful, right? Just to share a bit, one of the first projects we do, I remember I had this talk with Professor Mary Roth, one of the most senior gynecologists in Singapore, right? And during her time, she said that as a medical student, she would actually had the opportunity to be in the operating theater to actually deliver baby, right? I think she delivered about 10, during as a medical students. And today, that opportunity is not presented to many of the medical students due to a few reasons. I think one is that Singapore birth rate is dropping, right? But it's also less accessible to the delivery suite, right? So we started thinking about how can we use virtual reality to train students, right? And this is where we got started the project. We look into creating the simulation environment, delivery suite, simulating the mother, the baby, and the procedure how to deliver a baby, right? And in the first few years, we created the simulations, and we started to test with a small group of students and see whether did such a simulation help the students in learning, right? It's very important for us to quantify the outcome of the simulation, right? And in our studies, so in 2022, we started to do a large-scale studies, and it shows that actually the students actually learn better in VR as compared to mannequin. I'll explain it a bit, right? But let me share with you some of the features. We have three main features. One is the tool familiarization. The students get a chance to look at the environment. They actually get familiarized with the tools that needed for their procedures, right? They have a pop-up quiz. So this is quizzes that pop up so that it kind of enhance their learning as they go through this simulation. Not just the spatial understanding of the simulation, the procedures, but also the knowledge that comes with that in contextual way, right? That's presented to students, and also a virtual guiding hand so that students have to follow the the movements in order to complete the delivery. And this way, they can actually learn something more tangible, how they should maneuver the hands. Okay, and we carry out large-scale user studies with, this is year 4 medical students at the National University Hospital. So all the NUS medical students, year 4, who went to a NUH posting, go through our simulations. We split that into 2 groups. In the first group, we let them try the VR simulation first, before they do a mannequin simulation. And the second group, they would try the mannequin first before the VR simulation, right? And then we do a pre and post test, right? Before the simulation, we do a test to test their knowledge, how much they know about this procedure. And after the procedure, we do another test, right? So we measure what is the delta between the pre and post knowledge gain, right? And based on a study of 134 students, the knowledge gain, the VR group score a much higher gain, 4.49, as compared to 1.66 knowledge gain. This is normalized over 10, score of 10, right? So, and it's statistically significant. What it means is that VR did train better than a mannequin in this particular training. And we attribute that to the spatial understanding, right? When you train in VR, you get a spatial understanding, and you have contextual, information, the knowledge, and what you're doing. That's all good. But as all of us who are developers in this room will know that technology is not the silver bullet, right? Make a guess. They learn better, they score higher, but students don't like VR. What they want, no, we actually score them of a few other things like confidence, usability, enjoyment, feedback, and presence. All of them said VR is not so good, right? Because they are more familiar with mannequin, right? Many of them wanted to see the modality to combine with mannequin. And this is important in any developing technology, because we don't just create technology, but we need to understand how users perceive them, how users wanted to use them, right? So we listen to them, we combine it to make a mixed reality application. So, yeah, the result, if you're interested, the 2022 results we published in the SICAI, ACM SICAI conference. It's a conference in human-computer interaction. You can refer to this paper. And in the last 2 years, we look into combining virtual reality and the mannequin, put in together to be mixed reality. So we developed, you can see here, there's additional depth sensor that can detect the markers that we put on top of the mannequin. It can localize the mannequin, and we overlay the mother and baby so that the medical students can now train in a mixed reality system, something that they are very familiar with, a mannequin system, and overlay with the benefits that carried with virtual reality, or the digital spatial understanding. We bring that in, and we conducted a study. And it shows that the result is also improved in terms of procedural training. Our paper just got accepted into IEEE VR, into TVCG journal. So if you're interested, do look out for the paper. All the details are there, right? All right, I'm going to share a few other applications we have developed in terms of medical before I jump into aviation, right? So another early project we have done is the AI patient. We are very interested how we can create AI patient for medical training. As you know, medical school use a lot of standardized patients. These are actors hired to kind of rehearse and role play the scenario, so that medical students got the opportunity to work with a standardized or simulated patient, right? And we see a lot of opportunity. How do we use natural language processing, understanding? How do we use a large language model? GPT models. How do we make better understanding of the conversation? How do we create AI patient that the medical students can now work with them, right? So this is a paper we describe how we create an AI patient for orthopedic simulation. So this is for clinical assessment. Another project that we do is on, just now I mentioned, HoloFocus. This is a mixed reality ultrasound. So instead of just looking at a slice of the ultrasound, which is, most of the ultrasound devices today are 2D ultrasound, right? So the doctors can only see a slice of image, right? But there's some limitation, but we created 3D markers, we mount onto the normal probe, and with the HoloLens, that will transform into a 3D ultrasound, right? Which give the doctors a full anatomy understanding, spatial understanding of the anatomy, right? When project back to the body. Whether you're doing a thyroid scan, you're doing a liver scan, the doctors now can have a full view of anatomy placed into the correct placement. And this is how we work with this is a project at National University Hospital with the holomedicine program. Right, so you have 3D reconstruction. We can visualize the key structures all at once instead of only plane by plane. And this is actually a breakthrough in procedural guidance during point of care or besides diagnostic. Right, this will speed up the process of understanding for the diagnostic for the doctors. All right, with that, I'm going to jump in to share a bit of what we do with the Singapore Airlines in terms of aviation training. So we have 2 projects. I'm the principal investigator for 2 projects. This is part of the Singapore Airlines and US Digital Aviation Lab. It's funded through National Research Foundation. So I lead 2 projects. One is on the AR, VR, AI co-pilot training, and the other one is on cabin crew. So on cabin crew, we create AI passenger that we allow the cabin crew, instead of role-playing, they role-play now with tests with the actual simulated passenger in the environment. And this is where we can simulate different kind of aggression level, that the cabin crew need to then learn how to do the service recovery, right, in the steps that is required for part of the training. I'm going to share more onto the pilot training for this presentation, right? There's a soaring demands for pilot training in this region, in Asia Pacific, right? I think we are looking at the expansion of 5 to 10x throughput of training for pilots. We want to train more pilots. There's a lot more needs to train for pilots. But we all know that the full flight simulator is actually running at a maximum capacity, right? The big simulator is $6 freedom. It's actually very costly and it's always at a max capacity. So we explore with Singapore Airlines, how do we design and develop a portable system using augmented reality and a mixed virtual reality, that we can actually reduce the cost, creating something low cost, and we combine with the AI co-pilot. Because current training in the full flight simulator require 2 pilots, right? 1 pilot flying, 1 pilot monitoring, and also a pilot instructor in order to be able to train. But in this case, when we just do an AI co-pilot, a pilot can train on this anytime, anywhere with a portable device. And that significantly reduced the training costs. And that allowed more room for threats and error. This is an area that I think we explore in this research, where we created an AI simulated pilot. This is the Busan approach scenario. And then we inject threats and error into it and see how we evaluate how the pilot are trained to achieve certain competency. Right? So the user in this role is taking the role as a pilot monitoring. There's AI is taking the role of a pilot flying, right? Maybe I'll play the video how it looks like in simulation.
Sure.
We at National University of Singapore have partnered with Singapore Airlines to build a virtual reality flight simulator for operationally ready pilots to supplement their threats and errors management training. We worked closely with 5 expert instructor pilots with over 20 years of experience to design and refine training scenarios to ensure the VR flight simulator feels authentic. We have developed a cost-effective approach featuring an AI-simulated pilot and threats and errors management feedback. The pilots are able to talk to the AI-simulated pilot and air traffic controller and get an instant response.
Roger, landing checklist below the line. Landing gear.
Down.
Down. Speed brakes.
Arm.
The pilots are also able to interact with the virtual cockpit with natural hand interactions. These interactions, as well as eye movements, are recorded to aid in visualizing and assessing the pilot's threats and errors management competency level. This allows the pilots to focus on and strengthen specific competencies, equipping them with a well-rounded threats and errors management ability. For pilots, having the ability to manage threats and errors well is a vital skill to ensure the safety of the aircraft, as well as its crew and passengers. In our system, we introduce 3 primary threats and errors. Flight mode awareness check, aligning with the wrong runway and unstable landing conditions, across 2 scenarios for the pilots to identify and rectify. The industry standard full flight simulator is very costly. In comparison, VR headsets are orders of magnitude cheaper, and it allows the pilots to train at any time of the day and anywhere in the world.
All right, thank you. So I think one of the key things that we do with industry partners is to quantify the outcome of the training, right? Because I think it's important to quantify that so that we understand how did the pilot perform better. In this case, we created a random control trial with a control group that's no treatment, and then we actually put the 2 other groups go through a VR training, and the other one going through the full flight simulator training, which is the standard of the training today. All right? So we put them through an intervention on a Busan scenario before all of them are assessed on the Siem Reap scenario, right? So we want to see how does the intervention help the pilot in terms of gaining the competency. And we have carried out the user studies with 45 operational ready pilots. These are pilots who are flying with Singapore Airlines. And we actually checked, we actually get the pilot instructors to grade their performance at the end, how they perform, right, in this scenario, using the observable behavior here, 1 to 5. And our result shows that our virtual reality simulator, as compared to full flight simulator, is as effective for these 4 dimensions, for the flight path management, for communications, for knowledge, and applications of procedures and compliance. And these are important. It shows that, of course, there are other similar scenarios, for example, that require flight dynamics and all things. We can't train in the AR, VR, but these 4 scenarios, there's no statistical difference in the results from VR groups versus the full flight group. So it's as good, right? And our result further shows that the group that actually carry out intervention perform better in flight path management, right? Which is the part that we wanted to test them on. So this is the results are going to be presented at IEEE VR in South Korea next month as well. Right? If you're interested, you can read up the paper. But this is very, very promising results, showing that AR, VR combined with AI, actually we can train pilots at a level that is equal to actually the much bigger system. Right. So for this talk, I think what I wanted to highlight that this is a start. Hopefully this is a collaboration opportunity. Right. We are very excited because intelligence now is becoming spatial, more embodied and networked, right? So the intelligence is not staying with one person or one system, right? Now it's actually connected, it's spatial, right? And I think the value of AR, VR really shifted significantly, right? Especially now with the AI, large language model. It's no longer just about giving the visual realism, but it's about really the fact that we are able to now look at collective intelligence, right? How do we then facilitate that knowledge transfer between the person understanding what they are looking at with the other group of people, right? And I think that's the potential of changing everything. And VR, AR is actually a great modality because, let's face it, you have devices stuck to your face, right? You're recording everything. What you're seeing, you can understand that, but also internally, right? What you're looking at, right? What's your facial expression? What do you say, right? There's a lot of data, and I think this is the kind of the puzzle towards making this truly collective intelligence, right? I think AR, VR is the interface towards that, right? This is very, very exciting for all of us researchers in augmented reality and virtual reality, right? And I think collective intelligence is the ability of an individual or group of people to function, to understand a situation, reason, and act better than any individual alone, right? I think that's very powerful, especially in context of enterprise solution. I think this is very, very important. And our lab, we explore opportunities in healthcare, in aviation, and I didn't share here, but we also started many projects on creative media, on heritage experiences, entertainment. We started quite a number of projects there, but that's just the beginning. I think the opportunity is endless. There's a lot more opportunities, and we welcome any collaboration in any other area, right? Yeah, so one of the things that we want to do for our lab is to work with partners to look at from what we can do from lab to proof of concept to applications, right? I think one of the benefits of being in the university is that we have expertise across various disciplines, right? And this is one of the things I took advantage of when I go back to NUS, right? Because we have a great medical school, right? There's a lot of knowledge by the doctors, the professors in those domains, right? We can work together to create simulations, applications, that really actually would change how we actually train our doctors, how to kind of improve the patient outcome as well, right? So I think industry, partners, you all have the data, you have the real problems, you have the context, you also have the for deployment, right? You have the venue for deployment. I think this is where I think universities and industry collaboration could come together in a very meaningful way, and we can explore how we can discover some of this. We kind of explore, define that problem, and then look into how we can come up with a solution together, and then hopefully we can scale it and deploy in the industry, right? So I think the point I want to make here is that immersive intelligence is not just a technology stack, like what we have done a lot of technology, but actually it's a new collaboration opportunity. So with that, I would like to end my presentation and welcome any conversation after this. Thank you.